All right, so what we're going to be talking about today, everybody, is we're starting with this thing called direct variation. So if you would, please, right now, before we do problem number 1, I'd like you guys in your journal right now to write direct variation. So just write down direct variation. This is going to be very, very easy. You guys should feel very good after about this. So if you would, please write y equals k times x. Y equals k times x. Now, if you're wondering what k represents what's called the constant of variation. The constant of variation. All right. Now, the k value, the constant of variation, is always equal to the y value divided by the x value. This is going to be very useful when you're solving problems, okay? So here's one equation, y equals k times x, and the k value is always equal to the y value divided by the x value. That's what you want to make sure you have in your journal, because remember, you will be allowed to use your journal when you're taking different tests and quizzes, so make sure you have that written down. Now, this may not seem familiar to you, but something I'm about to write down should seem familiar. Now, this form is what form? Slope-intercept form. I'm going to put y equals kx right underneath it, and I want you guys to look how very similar these forms are. Does everybody see the m value right there? And you see this k value? What I want you guys to understand is they actually are the same. So when I say constant of variation, that's basically talking about what? It's talking about the slope in a direct variation equation. What's the only thing that's interestingly different? It doesn't have a b value, but you know what the b value is always going to be in a direct variation problem. It will always pass through the origin. So I'll put a little star here. A direct variation equation always passes through the origin. Well, what is the origin? 0, 0. That's what's known as the origin. All right, so what we're going to do right now is we're going to explore just a really basic direct variation equation. All right, I want you to write down y equals 4x. Y equals 4x. This is just an example, so I'm going to write the word example. All right. Now, we're going to make a little table right here. Going to make an x and a y table. Now, if that's y equals 4x, we know it has a what? 0 and a 0. If I plug in a 1 right here, if I plug in the number 1, what's 4 times 1? 4, right? If I plug in a 2, what's 4 times 2? 8, right? If I plug in a 3, what's 4 times 3? 12. Now I could keep going, right? I could just keep going, and I could put a 4 right here, and what's going to be right here? 16. Now what I want you guys to do, all right, is I want you guys to look at something interesting. Look at that ordered pair, that ordered pair, that ordered pair, and that ordered pair. What is 4 divided by 1 equal to? What is 8 divided by 2 equal to? So this is where you should see a pattern in a direct variation equation. What do you get when you take the y value and divide it by your x value every single time? You get your k value. Oh, yeah, by the way, this is in the form of y equals k times x, which is basically the same as y equals mx, okay? These are the same, okay? The only thing is we don't have to worry about the y-intercept being anything other than 0, 0. So this right here, this is an example, and we're going to take a look at, we're going to use Desmos so you can see how this works, and we're going to change what's called the constant of variation, also your slope. Go to Desmos, everybody. Go to Desmos, And what I'd like you to do is put y equals 4x, just like that. Y equals, yeah. But here's how you could make a table in Desmos. You hit the little gear button right here, and you go to a little place that says Convert to Table. You click on it, and it kind of gives you some points, but you can type in any point that you want, like 10. Or if I could put 20, all right? Or I could put 30. Now, what's interesting about this? Look at this. Every single time I take the y value and divide it by the x value, what do you guys get? What's the answer? 4. Now, look at this. What if I change that 4 to a 5? What do you notice about all the y values divided by the x values? They're all 5. If I change it to a 2, now everything is just what? Doubled. This is what I want you guys to understand. Direct variation is very easy because if you want to find the slope or the constant of variation in a direct variation problem, you literally just have to take the y value divided by the x value. But look what happens if I put a y-intercept other than 0? What if I put a 1? Uh-oh. Is 3 divided by 1 2? No. Does 5 divided by 2 2? No. So you guys see what happens when I move the y-intercept from say 0 0 to say a 1 or a, now it works, right? But as soon as I put say just minus 1, now guess what? Now it doesn't work anymore. Everybody see that? So what has to work in direct variation? What does it always have to pass through? That's what you got to remember. The origin. It's got to pass through the origin. All right. So let's go back to our little page right here. This is the formula I want you guys to write down that you're going to need for all of these problems. Ready? I want you to write this down. y1 over x1 will always equal the y2 value over the x2 value. This is what will be the case every single time. So if you didn't write anything down but had to write 3 things down, what should you write? What's in this box, what's in this box, and right here what's in this box. Those are the 3 most important. So now that you have those written down, we're going to take a look at the first problem. So here we go. There's our first problem. It says the mass of a substance varies directly with the volume. Could you underline mass varies directly with volume? When I say mass varies directly with volume, put m over v. Just put m over v. The volume of 100 kilograms, what is 100 kilograms? Is that dealing with volume or mass if you're dealing with kilograms? Mass. So I want you to put 100 kg over a substance that has 80 liters. What's 80 liters deal with? Volume. So put 80 capital L for liters. What is the volume in liters of 3.2 kilograms? So where am I going to put the 3.2 kilograms? Right up here, up top. And what am I going to put down here? I'm going to put a capital L, because what am I going to be solving for? I'm going to be solving for L. So this is the proportion. This is called a proportion. Now, you guys should have learned proportions in the 8th grade for sure. Now, what is a proportion? Quick review. You guys ready? A proportion is 2 equal ratios. Can anybody give me a fraction that is also equal to a half? This is just an example. Give me a fraction that's also equal to a half. You're right. 2 over 4. How about give me another one? 3 over 6. All right. How about 5 over 10? Does that still work? All right. Now, what makes proportions work? Check this out. Look at the cross products. What's 2 times 2? What's 1 times 4? Oh, cool. Change colors. Ready? What's 4 times 3? What's 2 times 6? Ooh, interesting. What's 6 times 5? 30. What's 3 times 10? So what do you need to know about proportions? Their cross products are always what? Yeah, cross products are equal. So if their cross products are equal, let's do some cross products. Let's multiply this together and multiply this together. All right? Well, how do I multiply 100 times an L? That's just 100 L. What's 80 times 3.2? Well, just take your calculator, do 80 times 3.2. So this is where you get your calculator out. Do 80 times 3.2. So here we go. 80 times 3.2. What do you guys get? 256. Perfect. So what do we have here, guys? We got 100 times an L equals 256. What do we do to both sides? We divide by a number. Anybody know? 100. Why are we dividing both sides by 100? Because we want these to cancel out. And when you do that, you end up getting 2.56 liters, which is the answer. So the answer to this problem, guys, the answer to this big little problem is just 2.56. And that in your answer document, you'd have to bubble it in. A 2, a decimal, a 5, and a 6. I'm not expecting you guys to know how to do everything right now. I am expecting you to write things down on the paper. The paper that I gave you, I'm expecting you to write things down. Okay? Now, here we go. Problem number 2. Right now, I want you to read it. Okay? And I want you guys to write this down. One wall inside a shoe store is dealing with 2 types of shoes. Walking shoes and running shoes. Could you please just write this down? Then I'm going to let you guys see if you can figure it out. Ready? We got walking shoes and we have running shoes. Does anybody know what the total is for the walking and the running together? There are a total of 135 shoes. Okay. Here's another thing. It says there are 1.5 times as many pairs of walking shoes as there are running shoes. So the walking shoes, there are 1.5 times the number of running shoes. What I'd like you guys to do right now, I'm going to pause the video, and if you're watching this, you can try to do it on your own, see if you can figure out the right answer. I want you guys to find the answer that meets this condition and meets this condition. Just remember, all the walking shoes are right here. Here's the walking, the walking, the walking, the walking. These are all dealing with the running, the running, the running, the running. So see which one of those works. So I'm going to go ahead and pause the video, give my class a chance to use their calculators and figure it out. All right, so when you guys are doing these problems, you want to make sure that you don't have to check all these answers. 2 of them are obviously wrong. Because what do we have more of? We have more walking shoes than we do running shoes. So which ones would we eliminate that would not be okay? We would eliminate what? G and H, because we're supposed to have more walking shoes, because it says there's 1.5 times as many. Now, what numbers would I plug in here to test to see which answer is correct? We're going to take 2 numbers. What's one of the numbers we could have tested? 45. What's the other number we would have tested? 54. So what we're going to do right here is we're going to take 1.5 and we're going to multiply it to the 45 and multiply it to the 54. So just go to your calculator, take 1.5, multiply it to 45. And what does it say? 67.5. So right here, this would equals what? 67.5. And that means you got what, half of a shoe? Okay? So that one's not going to be our answer. But if I took 1.5 and multiplied that by, is it 54? That's 81. Ooh, I like that. Because if we have 81 and we add that to 54, they add up to what? 135. Now, do these add up to 135? Yes, they do add up to it, but it didn't work in this scenario. So that's why J is the best answer choice. Okay? What would this answer choice? I could actually make this F if I said there are not 1.5, but 2 times as many. Because would you guys agree? Double 45 is 90. So if I wanted, I could give you guys this exact same problem and do what? Do one thing. Change that from 1.5 to a 2, and that's what would happen. All right, moving on to the next question. Right down here. What I'd like you guys to do is I am going to show you guys the least complicated way possible. So if you would please, write down this formula. Ready? L equals 0.8 capital T squared. But next to it, could you please put L equals the length, not leg, length of a pendulum. And T represents the time of the period. All right. Now, if you don't know what a pendulum is, okay? If you don't know what a pendulum is, you've never seen like a grandfather clock, but imagine like you have a grandfather clock, all right? And then what happens is something goes tick, tock, tick, tock. So imagine there's like a pendulum that has something right here like at a base, all right? And that's going what? That's going from left to right. Okay, so it's going along this path back and forth and back and forth. That's what's happening. Okay? You don't have to draw the pendulum. I just want to make sure people knew what a pendulum was. Okay? Now, it says which value is the closest to the what? To the period. So what do all of these answers represent? They represent what T would equal. So put equals T all the way down. Equal T, equal T, equal T. For a pendulum, all right, that is how many feet long? 30. So I want you to write 30 equals 0.8 parentheses squared. Now, what I need you guys to do right now is just take these numbers and test them. Take the numbers and test them. Find which one of these gets closest to 30. That's all I want you to do right now. See if you can figure it out. All right. Did anybody figure out what the answer was that they chose? What'd you guys choose? You chose J? Okay, so let's test it out. Ready? Let's put a 6.1 right in there. Now, if you don't have a graphing calculator, all right, I'm going to show you how to do it in Desmos if you don't have a graphing calculator. But it says 0.8. We're thinking it's going to be 6.1, and then we're going to square it. So that's where you square it right there. Okay? Now, let's say you don't have a graphing calculator home, but you wanted to try it in Desmos, you could still type it in, right? 0.8 parentheses 6.1 close parentheses, and you could do what? You could square it. So that's how you could use Desmos to do the exact same thing to test it. Well, that is the correct answer. It is answer choice J. But what if you didn't have multiple choice? What if you had to like do a fill in the blank? Here's how you guys would solve it. So if you would please, I'm going to show you guys how to solve it. Here we go. So the very first thing that you would do if you're trying to solve this equation without like having multiple choice answers is you would have to divide both sides by 8/10, which is this 0.8. So you divide both sides by 8/10. So in the calculator, just do 30 divided by 0.8. And what do you get? 37.5. So this right here, these cancel out. You're left with 37.5 equals a number T squared. So T squared. Now look right now. Look at your calculators. What do you see attached to this x squared? What symbol is right there? Can you guys see it? That's the square root symbol. So look what happens. If I take the square root of 37.5, what do you get? 6.1. All right? So how do you solve this? You don't divide. You take what's called the square root of both sides. And that's where we got that 6.12, which is approximately equal to T, which is this answer right there. So when you have to go from something squared to something that's not squared, you have to use what symbol? The square root. And that's how you do it. All right, moving on. All right, guys, these are real questions that students had to use on the STAR test. Some of these are ridiculously easy. All right. I don't know if you guys have ever been on a plane, but a plane has what's called a maximum cargo. Okay, so what is this plane's maximum cargo? 160,000 pounds. Now, a company uses these planes to ship containers. So one container, write this down, guys, one container, and you don't have to write this down in your journal, just writing it down on the paper. One container equals 2,000, I'm going to put LBS for pounds. So you got one container. The total cargo weight is a function of the number of containers on the plane. So here we go. You guys ready? The total weight, I'm going to put W, equals 2,000 times the number of containers. So I'm going to use C. So if you used Y and X, you'd say Y equals 2,000 times X if Y represents the weight and X represents the containers. Okay? Right now, here's your task. Your task is to figure out what is the greatest value in the domain. What the heck? What the heck is the domain? The domain deals with what value? The X value. So what I want you guys to do is I want you guys to figure out how many containers can they put on the plane so it does not go over the maximum. That's what you're trying to figure out. You're trying to figure out how many containers. Question. How many containers before it goes over the limit of what? 160,000. That's what I want you to figure out. Good luck. I will pause the video, try it, and then unpause the video and see if you got the answer right. All right, in order to solve this problem, what was the maximum weight? The maximum weight was 160,000, okay? And each container was 2,000. So if we divided both sides by 2,000, what did X end up equaling? 80. So there was a maximum of 80 containers. Does that make sense? Had to be 80. So, next problem. Good luck. Next problem. Guys, I want you guys to understand, number 5 and number 1 are literally the exact same type of problem. All right, so see if you guys can do number 5 on your own. Now, you can watch what I do. I'm not going to give you the answer, okay? But it says, in an electrical circuit, the voltage across the resistor is directly proportional to the current. Voltage across the resistor. So I'm going to put voltage over current. All right, okay, resistor. So I'm going to put voltage over the resistor is equal to the current. So I'm going to put I. All right, so here we go. I'm just going to write the word voltage. Voltage across is directly proportional to the current. So voltage over current. Now the letter V represents voltage, and I believe current represents I, because R is resistor. So I'm going to put V over I equals V over I. Voltage over current. So if a current of 12 amps produces 480 volts, so I'm going to put 480 on top, I'm going to put 12 on the bottom. How many volts, I'm going to put V right here, would a current of 1.5 amps produce? So here's your proportion. All you guys have to do is solve this proportion. Good luck. All right, what you guys should have done is cross multiply. What is 12 times V, everybody? 12V. What is 480 times 1.5? I believe it's 720. I believe 480 times 1.5 is 720. So what would we have to do to solve for V? Divide both sides by 12. So V is equal to 720 divided by 12. That's all you guys had to do. Which is what? There we go. Now, check this out. If I took 480 and I divided that by 12, do you know what 480 divided by 12 is? That's equal to 40. Well, what's 1.5 times 40? That's equal to 60. So this quotient, which is an answer to a division problem, has to equal this quotient, which is the answer to a division problem. So our voltage was equal to 60. Last problem, and then you guys will have a wonderful day and a wonderful weekend, is right here. This one is as straightforward as it gets. It does not get any easier than this, because what does this say right here? So I want you guys to put y over x equals y over x. I want you guys to write this down, fill it in, cross multiply, because we're not leaving until you guys get this done. All right, what you should have done is taken this 21 and put it over a 3 and set it equal to 105 over x. Now, when you guys cross multiply these, all right, you get 21x equals 315. But what do we have to divide both sides by? 21. And when you do 315 divided by 21, what do you get? 15. That's why the answer is J. Make sure, guys, make sure you have in your journals all of these notes about direct variation. And what does it always pass through, guys? It always passes through the origin. Have a good day.